Yes. Help me remember to pass the quizzes back. I have them graded. Yes. All right. This lesson goes pretty fast. It's pretty easy. I think you'll like it. Ready? Yeah, do you have a blue unit circle? Unless you have it memorized, then you don't need it. Parts of it, yes. Well, things like, what's the sine at 90? What's the cosine at 180? What's the, something like that you need. All right, guys, I'm getting started. We're already a minute into the video and I haven't said anything yet, so let's start over. All right. This is vectors in the coordinate plane, and honestly, I already taught you a bunch of this stuff because I like doing it the way we did in the last section where we do components, where we did the length of the vector or the magnitude of the force times the cosine of the angle and the magnitude of the force times the sine of angle. They're going to finally teach us that, and we already did it because we're just that smart. All right. First part of the lesson, though, talks about when you're given two ordered pairs. If I'm given an ordered pair like -3, 5, and another ordered pair like 2, 1, this says I'd go 3 to the left and up 5, and 2 to the right and up 1, and it wants maybe the vector that goes from there to there. There is an equivalent vector that is parallel and the same length that's here. Does everybody understand that? Guys, look. If this is A and this is B, and this was point A and this is point B, I could slide this down here and say this vector is equivalent, but it's at the origin. Okay? Equivalent means same direction, same length. Yes? So it's a parallel vector of equal length. So that's what they want us to do. They want us to pretend to slide it to the origin. What happens when you do that, if it says find the component form means we're looking for these guys, okay? The x and y components. If it goes from, well, I don't really want to draw this, but -4, 2 to +3, -5, A to B. Guys, what really happened was -4 became 3. So what happened? It went to the right, how many? 7? And the 2 that was up went to -5 down. So it went down 7. I do them in my head that way. I think I'm going from this one to this one. I'm going from this one to this one. If you want to subtract, you have to do it backwards. You have to take 0.2 minus 0.1. The order matters, okay? When we did slope, order didn't matter because it was the same slope whether you went from the bottom one to the top one or the top one to the bottom one, okay? When we did distance formula, the order didn't matter because we were going to wind up squaring them, remember? But if they want the components, I need to know that I was going right and down. Does that make sense? If you subtract them backwards, you'll get the opposite. And then it's like you went from B to A. That's all that happens, but it will be backwards. The signs will be wrong. All right. The other thing they're going to tell us is that the length of that vector can be found using distance, or once you've found the components, you can use Pythagorean theorem. Did we already do that? Yes, we did. We are good. Oh. This is an example that says you're going from X to Y. So from 2 to -4 is -6. We good? Down 6 or left 6, I guess. You could do -4 minus 2. That's what they did right here. And then the Y value went from -3 to +2, which was up 5, yes? To find the, if we regraphed that now, it would be left 6 and up 5. Is that same vector, well, pretend, slid to the origin. Does it make sense? Do you see what I'm talking about? They just slid it to the origin. Excellent. The magnitude just means what? The length, which is Pythagorean theorem. So negative 6 squared plus 5 squared square rooted. 36 plus 25 is the square root of 61, which is, I think, maybe 7.8 something. Thank you. Now, I will accept either answer. A lot of the next quiz is multiple choice, so you just figure out which one is equivalent to one of the answers that's there. Does that seem okay? Let's try 3 of these. It asks you only to find the components. Oh, and the magnitude. I lied. We need components and magnitude. Okay? So if you're doing it my way, went from 12 to 52, which is positive 40, and from 41 down to 33, which is down 8. If you're doing it, you can do 52 minus 12 and 33 minus 41. Gives you the same thing, okay? That's the components right there. And then to find the magnitude, we do 40 squared plus negative 8 squared, and square root is like 1664, I think, which is approximately 40.7. Okay. All right, can you do the other 2, guys? Practice, practice. Try to get it stuck in your head, this idea. Is it round to 40.8? Okay, sorry, that was my bad. I just wasn't listening very well. What's wrong? Oh. So are you saying I'm good at writing at this, or okay? I'm like, is this an insult or a compliment? Gotcha. 22 squared plus 19 squared is square root of 845. Did someone else get that number? Around 29.1. Are you guys all done already? Negative 3.1. Is that right? That seems like square root of 10. Yes. Negative 3, negative 1. Just kidding. But it's still square root of 10. I could make one that would turn out nice, but not very often. It's about 3.2. Okay, moving on. The next concept, you're going to like this one too, is using the coordinates or the component form. You can add and subtract vectors by just adding the x values or adding the y values, or subtracting the x values and subtracting the y values. A scalar, does anybody know what a scalar would do? This is, guys, we already used this concept. I just didn't tell you. Remember when we broke the vectors on the quiz down into components and then we added them together? That's all, okay? Scalar is if you had drawn a vector and you multiplied by a scalar, you'd multiply its length by, like, if I multiplied by 3, it would be 3 times as long. That's what multiplying by a scalar does. But all they're asking us to do is find ordered pairs. This is so incredibly easy. So if S is 4, 2 and T is negative 1, 3, what is S plus T? You add those and you add these. You liking this? Okay. This one says what's 3 times S plus T. So you have to take S's coordinates and multiply them both by 3 and then add T's coordinates. Seem okay? All right. So try these first 2. Got to subtract both the X's and the Y's. got negative 20, negative 23. Did anybody else get that? Okay. Yeah, this one's looking kind of miserable. I'm going to write it out. The G. What? I can't even write. Minus, I'm going to double F before I write it down. That seems like something I could do in my head. And I'm going to triple H before I write it down. And then I'm supposed to subtract and add. Anybody else get 13, 16? Anybody not getting 13, 16? You don't have to do it exactly the same way I did it. You could do it in smaller steps, whatever you wanted to do. Okay. This one is just misery. I would not give one like this on a test or quiz because we'd all make some little arithmetic mistake somewhere. Because these are all just numbers, let's do the parentheses first. Okay. So what is a G plus 2 H's? 2 H's would be a negative 2, negative 6. What does that come out to? Okay. And then it says take F, which was 4, negative 2, and subtract 2 of those, which would be a 4, negative 2. If you want to multiply through by a negative 2, you can, or you can distribute a positive 2 and then subtract. That's what I got. Anybody else getting what bus fun I got? Yeah, I don't ask one that's that messy. I will tell you, I just keyed the next quiz, and I got it wrong because it only gave 2 things, like maybe F and G right here. But then it said like 3G minus 2F, and I did 3F minus 2G because I didn't pay attention to the names of the vectors, okay? So just be careful that you write stuff down correctly. You know what I'm saying here? All right, unit vector. This also is not hard. Unfortunately, it's a little messy because it's going to have radicals, but it's hard because nobody remembers what it means. Okay, a unit vector, it says a vector that is magnitude and scale of 1. Magnitude of 1 is called a unit vector. It's sometimes useful to describe a vector in terms of a unit vector. So what they want to do, help me here, guys. I'm going to do a really easy one. If you went over 3 and up 4, how long would that be right here? 5. If you wanted the equivalent or parallel one vector, but only 1 unit long, you wanted it to only be 1 unit long, you would divide both of these by 5. It would be 3/5 and 4/5. Does that kind of make sense? 3/5 and 4/5, 1. Okay, so the definition is you find the magnitude, which is this little absolute value symbol. I kind of talked about that the other day, but when you put the components in the little absolute value symbol, it means find the length or magnitude, okay? And then you divide each of the components by that magnitude. And that changes it to a unit vector. This is a really weird definition. It looks really weird. They're saying 1 over the magnitude times each of the components. Okay, now that your brain is kind of going, what? Look here. Here's a quick example. Negative 2, 3, you find the magnitude. That's square root of 9 and 4 is 13. And then it started out with a negative 2 and a 3, and you just do this. That's the unit vector, which unfortunately we have to rationalize. All right? All you guys, there's one of these on the quiz, and it's multiple choice. The problem is no one remembers what a unit vector is. Unit vector, you take the two components and you divide them both by the magnitude. That's it. Unit vector. Divide them both by the magnitude. Now, the directions on this slide look tricky. Just ignore this IJ business. I'm going to talk about that in 1 minute. You're going to love it. It's super easy. But for this vector, I want you to change it to a unit vector. -4 squared plus -1 squared is what? Square root of 17. So I have -4 divided by square root of 17 and -1 divided by square root of 17. How does that rationalize? And notice I'm not saying how does it simplify, because it's no simpler. -4 root 17 over 17 and -1 root 17 over 17. You don't have to write the 1. Okay, disgusting, but if it's a multiple choice answer, we can figure it out, right? Just got to remember unit vector. Okay, do that 2 more times. Number 7, you're going to love. Sarah said this one is 4/5, -3/5, because it comes out nice. Remember a second ago? So what happens is, instead of going 4 units over, oh, just kidding, not up, and 3 units down, they went over 4/3 and down, or 4/5 and down 3/5. So they just shrunk it down so that this was 1 unit here. I suppose if you wanted to know, yeah, I don't know. All right, this one is disgusting, I think. 725, is that right? Okay, which is divisible by 25, 29 times, so it simplifies to what? 5 squared roots 29. Now, guys, your mumbling is going to be all over the video. When we reduce first, what happens here? That'll be a 2, and this one will be a 5, so then it rationalizes to, can anybody finish? Okay. So no fun, but you can remember what a unit vector is. Not difficult. All right, so many different kinds of questions today, but this is the easiest thing we're going to do all day. All right, I know this IJ business that electricians use, which I assume that means electrical engineers use when they talk about this stuff, but an IJ vector is I is equivalent to going 1 unit to the right, so a -I would be equivalent to going 1 unit to the left. A J vector is going up 1 unit, so a -J vector is going down 1 unit. So guys, this is as complicated as it gets. If they tell us the components are 3, 4, we're going to write 3I plus 4J. Yeah, it does say down here in the corner, Riley, do not confuse this I vector with imaginary number I. Imaginary numbers are italicized, but also you would be able to tell by the idea that you're talking about. All right, they call this, guys, it will say find a linear combination of the vectors I and J. Now, It's not hard at all. It says if you went D to E, -2 to 4 is up 6. 3 to 5 is up 2. But instead of writing that, you write 6I plus 2J. That's an I, not a J. Kidding. Yeah. All right, so can we try these two? If we went from M to N, we do what? -7. And from 8 to -3 would be -3 minus 8 or -11. So notice the directions say as a linear combination of the vectors I and j. So how would we write that? Okay, do the other one. Tell me what you get. Everybody get an answer? We all good? All right. Component form. The next thing it talks about is component form, and we've already done this, okay? Given a magnitude of 10 in a direction of 120, did I not already teach you to do 10 cosine of 120 and 10 sine of 120? The only difference is they want some exact answers. So we are going to pull out our handy dandy unit circle, and we're going to go, my example said 120, so I would have gone here and said the cosine is what? And the sine is square root of 3 over 2? So then when I went here, it was 10 times -1/2, 10 times square root of 3 over 2, and I got this answer. All right, we're going to do this one in exact form. What is the ordered pair here? Find me 240. You got your unit circle out? Okay, so this one is the cosine and this is the sine, yes? So when you write, I'm going to write this out so you remember what we did, but it was 18 cosine of 240, 18 sine of 240. So that will be 18 times -1/2 and 18 times negative square root of 3 over 2, -9, and no, because it will not give you an exact answer. The calculator will give you the decimal equivalent of that, yes. Okay. And if it was a multiple choice question and they were exact answers, you could type them in and find the decimal equivalent. Okay, same thing, but it won't give you exact. Okay, can we do 12 on the unit circle? No, because it's 95. So we just get to type 5 cosine of 95 and 5 sine of 95. That being said, I'm taking a commercial break to tell you this upcoming quiz is probably the hardest quiz this semester in terms, it's not hard overall, but in terms of you have to switch back and forth between radians and degrees several times. When we review for the quiz, we'll talk about which problems you need to be in radians and which you need to be in degrees. But you have to know that on the actual quiz, okay? It doesn't say by every question, change your calculator. But as we review for it, I'll help you. This one is obviously in what? Degrees, because the question was in degrees. Anybody give the decibels for me? That look good? Okay. All right, now direction we've already done as well. they go through this whole thing. It says the magnitude times the sine divided by the magnitude of the cosine is, these cancel and you get sine over cosine, which is tangent. And didn't we already do this inverse tangent of the y value over the x to find, that's supposed to be an x, to find the, yeah, to find the angle or direction yesterday, right? On the quiz, or the day before and the day before that? Okay. So to find the angle, there's one trick to this. Remember the business about what quadrant we're in. This one looks all nasty because it's got i's and j's, but it's got a 3 and a 7. If you do inverse tangent of the y over the x, or 7/3, you get this. Was the vector 3, 7, whose components were 3, 7, was that in quadrant 1? So we're done. This next one, 4, -5, is that in quadrant 1? No. When we do inverse tangent, it gives us -51.3. 4, -5 is in quadrant 4. Is -51.3 in quadrant 4? Yes. So I would take that answer. If you added 360, you could also call it 308.7. Okay? Do you remember the colored unit circle, guys? The problem is the calculator, when you do second tangent, do you remember where we colored for tangent on our colored unit circle? First and fourth. It only ever gives you a first or fourth quadrant answer. So if we're in quadrant 2 or quadrant 3, the calculator gets it wrong. So we have to add 180 to move across into the proper quadrant. Does that make sense? So this question, can you do real fast for me? Inverse tangent of 2 over -6, because that was -6 to y over x. We good? Gives you what? -18.4. Are we in quadrant 4 though at a -18.4? -6, 2. That's quadrant 4? -6, 2 is over in quadrant 2. Left 6 and up 2. Quadrant 2, yes. You're confusing me. So if we add 180, 161 point something, 5 or 6, which is the correct quadrant, yes? That's hard to say. Correct quadrant. The tongue twister. Okay. This one is a negative. Can you do inverse tangent of -8 over -3, which would turn out to be positive, which would place it in which quadrant? First quadrant. What'd you get? 69.4. This is definitely not a first quadrant set of coordinates, so we have to do what? Add 180. Okay, so let's talk about these two. What quadrant should this come out in? Maybe you should plan ahead. -4, 2 is in quadrant 2. So if I do inverse tangent, 2 divided by -4, 26.6. Okay, that's not in the correct quadrant. It thinks I'm over here because it only knows to find me answers in quadrant 1 or 4. So I add 180.4. This vector was in quadrant 2. So yes, we have to, yes, with the positive x-axis. Yes. Direction angle, unless it's a bearing, is with the positive x-axis. Okay. 217, are we going to have to do any crazy business? No, it's quadrant 1. What do we get? 83.3. Can I do that? Okay. All right. We have almost 15 minutes left. What I would like to do is the application problems off the homework. Would that be really nice to get those done together? So take a piece of paper. And I'm going to go through ideas on the bookwork. What? Oh, yeah. Well, you're getting out a piece of paper. All right. Quizzes pass back. I'm going quickly through the basic ideas of this. So tell me if you have struggles with the directions. Otherwise, I'm just going to do the word problems. You have to do these 3. Does this seem like something you could handle? Find the components and then find the magnitude. The next set are like this. You got to do a couple of these. That's easy? Okay. This is number 19. In physics, force diagrams are used to show the effects of the different forces acting upon an object. The following force diagram could represent the forces acting upon a child sliding down a slide. There's friction, there's the normal force, and there's the weight of the child, okay? Using the blue dot representing as the child is the origin. This is the child, and we're going to call that the origin. Okay? We're supposed to write each of those as a component form. This is super easy, guys. Friction. How would you describe this vector? The normal force. I'm not taking time to write these very nicely. And the weight of the child, how do you write straight down? That's all it wants. Part B says find the component form of the resultant vector. Well, if all of those forces are acting together, what are we going to do with their components? Yes, good guess. -9 plus 76 plus 10 is, yeah, plus 0. I said 10 and it was a 0. And 10 plus 84 plus -170? 76? Okay, so the child went forward and down. Does that make sense? Seems right to me that the slide would do that. Okay. This next question section, it asks for the unit vector. Are you going to remember how to find unit vector? Probably not, but you'll look in your notes, right? Okay. All right. The next section says linear combination of the vectors I and j. So that's where you find their components and then you throw in an I and a j, right? Okay. Here we go. This question is a little bit trickier than it sounds. It's not really bad. We're going to write each each of these little pieces of her story as a vector, and then we're going to add them up. It says she drives north 2.4 miles. Then she turns left for 3.1 miles. But then she turns right. If you're going left and you turn right, what's happening? Yeah, she's going up again for 5.8. That's the part that kind of messed me up. Okay. Now what? Well, we can, but we're just going to write them as components. What's her little first piece of the story here? 0 and up 2.4. The second piece was left 3.1, so, and then straight up 5.8 again. Okay. Express her total commute as a linear combination. Negative 3.1, and what did you get? 7.2, 8.2. I can add. Yep, 8.2. I can't read it because my bifocals, but yes, we need it in IJ form. Does that seem okay? I think I know they use the I and J, like I said, did I say it already? Electrical engineering and electrical stuff, they use the IJ form, and I don't really know any more than that. Okay. Nadia is rowing across the river at a speed of 5 kilometers per hour perpendicular to the shore. The river has a current of 3 miles per hour heading downstream. At what speed is she traveling, and what is the angle she's traveling with respect to the shore? This would be a really good quiz question. Do you want to draw the river going left to right or up and down? Doesn't matter. I did up and down too, but we can do left to right. Okay, here's the river. She's trying to swim across the river. Okay, guys? She's going 5. The current is pushing her 3. So her total resultant, how are we going to find her speed? We can just do Pythagorean theorem. We could write those as components, but we're just going to end up doing 5 squared plus 3 squared, which is square root of 34, or about 5 point what? And that's miles per hour. Does that make sense that the river pushes her a little bit faster? But it's not helping her a ton because it's kind of at opposing purposes to what she's doing here. Now, what angle is she traveling with respect to the shore? This is a little bit foggy. If we do inverse tangent of 3/5, what do we get? Okay, almost 31 degrees in here. That's definitely not the shore though, right? We could subtract from 90 and get this one, which would be 59. Somebody said, well, how do you know it's not this one? And I really don't. If we'd added 90, this is 121 degrees on this side, right? Because there's shore on both sides. I would have said 59 degrees. She was trying to make it 90, but it was down to a 59 because the water was pushing her. So, but I don't really know which way they want the shore to be counted. All right. One more application. Okay, let me go back. This one, it just wants the components, guys. So you do 12 cosine, 12 sine. Why do I have those circled? Yeah, we can use those, unit circle on those, right? The other ones you can just type. Okay. This says find the direction only. Why did I write check Q? Yeah, because some of them you'll have to add 180, right? Okay. This is, oh, we never got to 53 today, but we'll do 52. Maggie is pulling a sled with a force of 275 newtons by holding its rope at a 58-degree angle. Her brother is helping to push the sled with a force of 320 newtons. Determine the magnitude and direction of the total resultant force on the sled. He's invisible. He's going to run up from behind out of those trees, apparently. Okay. It doesn't matter if we say this is going left or right. It's the same difference. If you want to say it's going left because that's what it looks like, how would you do the components of that vector right there? Be careful. Yes, if you're going to say that way, it's got to go this angle, right? Which is, okay, so 275 times the cosine of 122 and 275 times the sine of 122. I'm not even going to calculate that yet because he is pushing straight left 320. So what would that look like? So how do we determine the resultant? This is what didn't go so well on the quiz yesterday for some of you. Add these and add these. What's wrong? It will be negative. The cosine of 122 is negative. Okay? Yep. 275 cosine of 122, and then add to that a negative 320. I don't know. I did it wrong. Somebody tell me what you got. That's what you got? Okay. And then 275 sine of 122, 233.2. Okay. That doesn't answer the question. Magnitude and direction. Yes. Still got to do Pythagorean theorem. Just like on the quiz, and some of you didn't get that question right, even though I did the exact question the day before, but I'm not upset at all. Just sad. Just sad when I was grading. 520.8 newtons? What was it? Yes. Okay. That's the total force exerted on the sled. Now, it wants a direction. If we do inverse tangent, 233.2 divided by negative 465.7. Inverse tangent, negative 26.6. Well, that's definitely, she's not going down into the ice. She has shoes. They're very tiny little shoes, apparently. Yes. Oh, they're boots. That's what it is. The heels are a different color. Okay. 153. Does that make sense, guys? That she ends up going from this, if we're counting it that way, 153 degrees, right? If from that way. Okay. All right. See you tomorrow.